Okay, so this is the proportion corrections for inference, and I hope this goes well. This will be question number 2. So Swedish researchers investigated the relationship between chocolate consumption and stroke. The researchers gave a questionnaire about eating habits to a randomly selected sample of Swedish men. Based on the responses to the questionnaire, the men were classified into 2 groups. Group A, consisting of 9,250 men who ate the most chocolate, and Group B, who ate the least chocolate. All right. So we have sample sizes that are the same. The researchers tracked the men's health for 10 years. During that time, there were 458 cases of stroke among the men in Group A and 543 of the cases of stroke among the Group B. So does the data provide convincing evidence that Swedish men who would be classified in Group A have lower probability of stroke than those who would be classified in Group B? So we have our null hypothesis, and our null hypothesis is that Group A has the same amount of stroke as Group B, and this is Group A is less than Group B. And what was Group A? Group A is the true population proportion of strokes among men eating the most chocolate, and Group B is those eating the less chocolate. So we want to know whether those eating more chocolate have fewer strokes than those eating the most chocolate have fewer strokes than those eating the less chocolate. Okay, so this is an observational study. We did not assign them treatments, all right? So we have a random sample here of people who are eating chocolate. So random sample, we must address that given, and it's 2 samples of 9,250. We need to make sure that we address both. So either you need to say it here or you have 2 samples. Reasonable to assume the samples are independent. One group stroke rate should not impact the others. And is less than 10% of the population. Reasonable to assume that there are 92,500 who eat copious amounts of chocolate or most chocolate, and it's reasonable to assume that there are 92,500 men who do not eat a lot of chocolate in Sweden. Then we have to address normality, and we have to address it for both groups. And once again, you didn't have to have the formula. You could have just used the counts. So we had 458 cases of stroke and 8,792 out of the same group who did not have stroke. Both of those are greater than 10. We had 543 from Group B who had stroke and 8,707 who did not have stroke. And both of those cases is because we subtracted 9,000. We had 9,250 minus 543. That gave us this. We had 9,250 minus 458, giving us that. So both samples are large enough to use the normal approximation. Okay, and then we calculate our p hat. P hat is x over n, so 458 over 9,250, 0.04. So this is p hat A for Group A. And for Group B, 543 strokes out of 9,250, so 0.0587. But because we're running a hypothesis test for proportion, we have to use our other formula where we pool or combine. So this is where we're going to pool or combine. And you have to show this. So 458 plus 543. And then we had our 2 sample sizes, and they happen to be the same size, and we ended up getting this proportion. So then I needed to show my work, which is p hat 1 minus p hat 2. So the 495 minus the 587, those coming from here and here. And then our combined is in the denominator over our sample sizes. And it just happened that our sample sizes are exactly the same. So then I need to go run the test. And I go to stat test to proportion z test. X1 had 458 out of 9,250. X2 had 543 out of 9,250. And our hypothesis was that we wanted to have a less than. When I do that, I end up getting a z-score of negative 2.76. So we want the probability that z is less than negative 2.76, and you have to have that. And our p-value ended up being pretty small at 0.00286. They did not tell us alpha, so when they don't, we like to use 0.05. So p-value 0.00286 is less than 0.05, so we're going to reject the null, and our conclusion is our p-value is 0.00286. We reject the null. There is sufficient evidence that alpha equal 0.05 to suggest the true population proportion of stroke victims who eat lots of chocolate is less than those who eat very little. So in other words, you eat a lot of chocolate, you have less strokes. All right, so let's look at our scoring. And on our scoring, the first point came from the conditions and defining it. You had to define the parameters, write the null and alternative, and give the conditions. That got us 1 point. The next point came from all of your calculation work, which means you had to show how you got your pool. You needed to fill in the equation. You needed to get z star, and you needed to calculate the correct p-value. That would get you another point. Then we have the conclusion, and the conclusion is we rejected the null and the sentence stem. That gets you the third point. The fourth point comes from part B. So it says, report in a newspaper concluded that Swedish men can reduce their probability of strokes by eating more chocolate. Based on the description of the investigation, was the conclusion appropriate? A little bit tricky here. We said it was an observational study. So although the results were statistically significant, and they were, the study was an observational study and not an experiment. Consequently, we cannot draw a cause and effect relationship. The article's conclusion was inappropriate. They cannot make that conclusion. I had several students say treatments were not assigned, so we cannot show causation. They said that, and that was great. All right, they can only show a correlation, and there is a correlation. It's highly related. It's statistically significant. We have a lot of evidence to say that there's a relationship, but we cannot say it was causation because it was not an experiment. All right, I hope you'll join me for the next video. This is your Stat Sensei. See you on the next one.